7.3 Rational Exponents. This is something that you probably haven't seen before, so it's actually probably good I'm making a recording. I have to make a recording of this to give you some help with this stuff and something to refer back to in case you need to review some of the ideas here. So, what does this mean? There's a little thing here about we're going to get back to later about sunscreen to prevent. There's an equation. The percentage of sunlight that's absorbed, P equals 50 times F, which is a particular SPF raised to 0.2. Now, whatever that F has to be depends on what the percentage is. So we're going to figure later on, you're going to solve an equation in which you figure out what F is. Believe it or not, huh? So here we go. Rational exponents are exponents that are fractions. Now here we're combining two of the things you probably hate the most, exponents and fractions, and we're making them into the same thing. So here's a nice thing to celebrate your snow day with. All right. B to the 1, so the denominator of a rational exponent, let's take this b to the 1/2 here. So we got b to the 1/2. What does this mean? We're going to find out this is exactly the same thing as the square root of b, where the denominator is the root. Now, let me write the square root symbol a little bit bigger here. The number that goes in here, the root, is called the index. Now, when we have the square root, we normally don't write the 2. So the default index for a root is 2. So b to the 1/2 equals the square root of b. And if we had b to the 1/3, that would equal the cube root of b. I just got to pause for a second because I got to set up my file here. I'll be right back. Okay, so I got my file set up here. Now let's go on to the next page. We got a little thing here. So for any non-negative real number, b to the 1/2 equals the square root of b, and so on. Okay, depending on what the root is. Now let's just go through the examples here. The best way to learn this stuff is just to do it. We're going to write each expression in radical form or each radical in exponential form. 25 to the 1/2 is the square root of 25. Very straightforward. Square root of 18 is 18 to the 1/2. 5x to the 1/2. Now the only thing that's getting rooted here is the x, not the 5. The only thing that's raised to the power of 1/2 is x. 5 is not being square rooted. So 5x to the 1/2 equals 5 times the square root of x. Okay, the square root of 8p. The square root of 8p is going to equal, now the 8 and the p are both under the radical sign, under the vertical bar here on the radical sign, so they're grouped together. That vertical bar is a grouping symbol, so we replace it with parentheses when we put it in exponential form. So the square root of 8p equals parenthesis quantity 8p raised to the power of 1/2. All right, now you are required to turn in guided practice on Thursday. So let's do some right now. And let's work through these, or you can go ahead and just do them on your own because you can see them right here. Just please put them on a piece of paper labeled with today's date and 7.3. All right, so we're going to take each expression and we're going to write it in radical form if it's in exponential form, or in exponential form if it's in radical form. So 1a. A to the 1/2. Well, that's in exponential form, so that's going to be the square root of a. And that's that. And let's move down. Some more space. Okay. 1b. Square root of 22. That's in radical form. 22 to the 1/2. 1c. Quantity 7w in exponential form raised to the power of the 1/2. Square root of 7w. Getting the hang of this? It's not too bad so far, huh? Okay. 1d. All right, now we have a number. Not in exponential form. That's the 2 times the square root of x, which is in radical form. And so this will be 2x to the 1/2. Okay, there's our guided practices. On to the next page. Now, find the square root of a number. You find a number that with a square of a. You can find other roots of numbers. If a cubed equals b, then a is the cube root of b. Okay, so what they're saying here is that roots and powers are inverses of each other, and you can use the inverse properties to find these things. Let me make this a little narrower here so I don't run out of my margins. Okay, and I can get more stuff on a page. Okay, so if you can, now I'm just rewriting this. A to the n equals b, then a equals the nth root of b. Okay, now you got 2 to the 4th equals 16, right? Okay, so 2 equals the 4th root of 16. So in addition to the inverse operations that you already have, such as, what inverse operations do we already have? Well, we got plus and minus, and multiplication and division. Those are all inverse operations of each other. And now we have root and power. Let's just say root and power. Inverse operations of each other. And just like we use the plus and minus inverse operations and the multiplication and division inverse operations to solve equations, to find unknowns, we will use the reciprocal operations of root and power to solve equations in a little bit. Okay. Now, even roots have plus and minus solutions, right? So in other words, the square root of 9 equals plus minus 3. Why? Because 3 squared equals 9 and negative 3 squared equals 9. Okay, but the positive root for an even root, the positive solution for an even root is the principal root. Okay? So radical symbols indicate principal root. So the answer to the square root, to the 4th root of 16, for example, is 2, not negative 2. That's the only thing principal root means. It means the positive root. You only worry about principal roots when the root is even. Okay, now let's move this down and let's do our example 2. Okay? We're simplifying cube root of 27. You can see here is going to be 3. 3 times cube root of 3 times 3 times 3, which is 3. You have to write it out like that. 5th root of 32 is 2. 2 to the 5th. As I've mentioned before, it's really useful to you in this chapter to know the powers. You want to know perfect cubes. It's good to know perfect cubes up to 7. It's good to know perfect squares up to 15. And it's good to know the powers of 2 to 10. So, let me write down here the stuff you really ought to know. Perfect cubes to 7. If you have these memorized, you'll save yourselves a lot of trouble. Perfect squares to 15. And powers of 2 to 10. In other words, up to 2 to the 10th. Okay. Let's do our guided practice. There's not very much. So we got 2a, GP. Well, we already know this. We've done the cube root of 64. We've seen 4 cubed come up a whole bunch of times, so that's going to be 4. Now remember, we're just doing the principal root. Well, that's cubed, so it doesn't matter. That's an odd root, so there's only one answer for an odd root, and that's 4. Negative 4 is not a root of 64. Okay, and then 2b. Now here we have a 4th root. Okay, 10,000. Yes, 4th root. Okay, now that's got to be, we got 10. That's going to be 10. Okay, because we're just costing out 4 zeros. So 10 to the 1st. Okay, so there's your, now let's move on here. I think we're done here. All right. Nth roots. Now, what are they talking about here? This is kind of a roundabout way. You see b to the 1 over n raised to the n. Well, that's going to equal b to the n over n, which is b to the 1st, which is b. All right. This is kind of just a restatement of what we've been saying so far. So b to the 1 over n equals the nth root of b. All right. This is kind of not really new territory. We sort of talked about this already. Okay. And then they restate it here. B to the 1 over n equals the nth root of b. All right, so here's some examples. The cube root, 125 raised to the power of 1/3, okay? Which can be rewritten as the cube root of 125, which is going to be 5. Here's another 5 cubed. That's come up a million times. Now, here's one you don't know, and I wouldn't expect you to know this. You'd need a calculator to figure this one out. 1296 raised to the 4th root, but in this section and what we're working on, you should expect that this would come out evenly. But like I said, I would, if I threw something at this at you, I'd let you use your calculator. But it turns out to be, so we take the 4th root of 1296. It turns out to be 6 to the 4th. So the 4th root of 6 to the 4th is going to be 6. All right. Guided practice. 3a. 27 raised to the power of 1/3 equals the cube root of 27. The cube root, the cube root of 27 equals the cube root of 3 cubed, which equals, let me skip this part here, which equals 3 to the 3 over 3, which is 3. All right. Now, you don't have to do all that stuff in between. You can just figure this out, okay? But just so you know where this is going. All right. 256 to the 1/4. This is 3b. Here, let me put 3b up here in the corner. Okay. This is going to be the 4th root of 256. Now, you may have remembered that 4 cubed is 64. If you take 64 times 4, you don't have to be, that's not too hard to figure out that that's 256. So the 4th root of 256 is the 4th root of 4 to the 4th, which is 4 to the 4 over 4, which is 4 to the 1st, which is 4. Like I said, if you want to go from here right to here, that's okay. As long as you understand how you're getting there. That's the main thing, okay? All right, now we're going to get a little more involved. Okay, and what does that mean? Okay, well, now the denominator is going to be something other than 1. Okay, so they talk about b raised to the power of m over n. Now, what does this mean? M is the power and n is the root. M over n is the exponent. The numerator is the power and n is the root. So you could rewrite this as b raised to the power of m taken to the nth root. Okay? You could also write this as in this form. These are logically equivalent, or mathematically equivalent, I should say. Okay, these two things equal each other. Okay, it doesn't make any difference. However, in terms of simplifying an expression that has a power and a root, it is nearly always going to be easier to first take the root and then raise the result to the power. Just because then you're always going to be working with smaller numbers. Okay? So they have an example here. Now let's look at it. 8 to the 2/3. 2 is the power, 3 is the root. Now you rewrite it as 8 squared cube root. Now, this one's pretty easy because 8 squared is 64, and we all know by now that the cube root of 64 is 4 cubed, so the cube root of 64 is going to be 4. In fact, you can't take the square root of 8, so you really have to first raise it to square it. I guess what I should be saying is that when you can reduce it evenly, reduce it. If you can't, you got to raise it to the power and then take the root. And so this will end up being the cube root of 64, which of course is 4. Or the cube root of 4 cubed, if you want to do that, and then we end up with 4. Okay. All right. Now they have 64 to the 2/3. Okay. Now here's what I was talking about. Okay. You can see it in the examples. This will be 64 squared cube root. Okay. Now 64 squared is a hard number to deal with, right? However, we know the cube root of 64, which is 4. So we can think of it like this, and they do this in the example. The cube root of 64, you don't have to write this down, but I want you to do the thinking. Okay, well, the cube root of 64 inside this parenthesis now, excuse me, is 4. So we end up with 4 squared, which is 16. That's easy. As opposed to taking the cube root of 64 squared, whatever, I don't know what 64 squared is, some big number. Okay. And the same thing here with 36 cubed, big number, don't know what it is off the top of my head, square root. I know what the square root of 36 is. It's 6. 6 cubed, I believe, is 216. Oh, there it is in the book. Okay. All right, so that's your strategy. Work from the inside out when possible. Okay? When you can do it. All right, so let's do these GPs here. So we got 4A, 27, and let me go down to the next page. 4A. All right, 27 to the 2/3. We'll write it like this. The cube root, remember, the root is the denominator, 27 squared. Now, we don't want to square 27. I mean, you could. But let's think about this while we're doing it. This is no calculator. So this is, again, this is how I want you to think of it. If it helps you to write it out, write it out. And we all know the cube root of 27 is 3. We got 3 squared, and that is, of course, 9. All right, so that's not too bad. Okay, 4B. Okay, 256 to the 5/4. Okay, the 4th root of 256. By now, we know what that is. raised to the 5th power. Okay? Now, the 4th root of 256 is going to be 4. Now, 4 to the 5th equals 2 to the 10th. Now, how did I do that? Well, we're going to work on this in the next section. But you could think of this as 2 squared, right? 2 squared equals 4, raised to the 5th power. And that's 2 to the 10th, which, of course, is 1024. Okay, because by now you've all memorized the first 10 powers of 2. Okay. Now I have run out of pages. I got to add a few more pages, so I got to pause here for a second. Okay. Moving on. Now we're going to solve. Remember I mentioned solving these equations. Okay. All right. In an exponential equation, variables occur as exponents. Now that sounds really awful, right? Okay, the power property of equality and other properties of exponents can be used to solve exponential equations. So, this is really important, okay? If, here, let me turn on my pen here. If b to the x equals b to the y, so in other words, you got 2 exponential expressions where the bases are the same, then x must equal y. Has to. Now, by the same token, if, if a to the x equals b to the x, then a must equal b. Okay? So you got 2 exponential expressions. They got different bases raised to the same, or they look different, okay? But they're raised to the same power. Then the bases have to be the same. Now, what I'm saying is that you could have a variable down here or something. They're going to turn out to be algebraically the same. All right, so let's see how this works. Let's do a few of these. Now the trick, this is a game. The trick is to recognize, the trick is to make both sides have the same base. Let me write that out. Make both sides of equation have the same base. Okay, so the first example they give us, here, let's go down. Okay, 6 to the x equals 216. Okay, well, I told you to memorize the perfect cubes up to 7. I know you've done that by now. So if you have, and I know you have, you know that 6 to the x equals 6 cubed. So we got 2 exponential expressions. Sorry about that. We got 2 exponential expressions with the same base. 6. Therefore, their exponents must be equal. So we just write x equals 3, and there's the answer. Okay? And you can check it. 6 cubed equals 216. Okay. Not much to check there because you didn't do very much. Okay. B. Example B. 25 raised to the power of x minus 1. There's an interesting power for you. How do you like that? Okay. Equals 5. All right, well, everybody and his kid brother knows that 25 equals 5 squared. So we write 5 squared, put it in parentheses, raise it to the power of x minus 1 equals 5. Now, we can't go ahead with this equation yet. We must do something first. Namely, we must eliminate the parentheses and distribute the 2 times the x minus 1. So we're going to have 5 5 raised to the power of 2 times x minus 1, in parentheses, equals 5. Okay, so we got 5 now to the 2x minus 2 equals 5. So 2x minus 2 equals 5. 2x equals 7. X equals 7 halves. Is that right? 2x equals 2x minus 2 equals, look at the mistake I made. Can't believe this. Equals 5 to the first. Sorry, guys. And this thing keeps... So we got 2x, 2. We got 5 raised to the power of 2x minus 2 equals 5 to the first. 2x minus 2 equals 1. Okay, 2x equals 3, x equals 3 over 2. All right. Fortunately, you had the example to follow along there, which did not make my mistakes. All right, now, guided practice. You work on those for a second. I'm going to pause this for a second. I got to add still more pages. Okay, guided practice. 5A. Five to the x, you probably figured these out already, equals 125. 5 to the x equals 5 cubed. X equals 3. All right. Now, 12 raised to the power of 2x plus 3 equals 144. 12 raised to the power of 2x plus 3 equals 12 squared. 2x plus 3 equals 2. 2x equals negative 1. X equals negative 1/2. And that checks. So if I plug in negative 1/2 for x, I get negative 1 plus 3, which is 2. 12 squared is 144. Okay. Now, one last part here. We're going to go back to the sunscreen thing. Remember, I promised you are going to solve an equation involving this sunscreen equation. So we got P equals 50 times F raised to the power of 0.2. So what is the SPF that absorbs 100% of the sun's rays? So let's look at the steps here. So we plug in 100 for P. So we get 100 equals 50, P raised to the 0.2. Divide both sides by 50. 2 equals F raised to the 0.2. 2 equals F raised to the 1/5. Now, this next maneuver, take a look at it. They take 2, raise it to the 5th power, and then multiply it by the rational exponent 1/5. And as they say here, so 2 raised to the 5th power raised to the 1/5 power. So we use the power of product, so we got 2 to the 5 over 1 times 1/5 equals 2. So we haven't changed the base. We haven't changed anything. Okay? But now we've got the same exponent and we've got the variable as one base, and we've got a number as the other base. So now we can eliminate the exponents, and we can make the bases equal to each other. So we've got 2 to the 5th equals f, and f equals 32. Okay, so let's see if we can do the same thing here with our guided practice number 6. Okay, so let's move down to a new page. GP6. Now this looks, the radius r of the nucleus of an atom of mass number A is r equals 1.2 a to the 1/3. Okay, find a if r equals 3.6. All right, so we're going to put in, so we have r equals 1.2 a to the 1/3, and we're told r equals 3.6. So we're going to have 3.6, that was equals 1.2 a to the 1/3. Let's divide both sides by 1.2. So we're going to have 3 equals a to the 1/3. Okay, now we're going to do this trick where we're going to do this maneuver. That's not really a trick, but we'll call it a maneuver, an algebraic maneuver, in which we are going to give 3 an exponent of 1/3. And we're going to do it by cubing 3 and then raising it to the power of 1/3. Note that this number remains 3. So we haven't changed the left side, so we don't have to do anything to the right side. So we can drop the exponents and we can make an equation out of the bases. 3 cubed equals a, so a equals 27. Now, first I want to just check the book real quick and make sure that's the right answer. Now, how would we check that? We would put in, yeah, that would work. Okay, let's check it. So 3.6 equals 1.2 times 27 to the 1/3. 3.6 equals 1.2 times 3, and 3.6 equals 3.6. Okay, so you got your guided practices done. So make sure they're all finished and everything. Get your name on them. Be ready to turn them in on Friday and start on the homework. I will post stuff, post help with the homework later on, but not right now. That is it. Email me if you have any questions.